Hey everyone, this is the Math Nexus, and today we are going to start with exercise 2.7, which is the exam exercise for chapter 2. Now, there will be no new concepts in this exercise. However, the questions will be a little more tricky, but if you have practiced and you have clarified your concept, you will not find any issues in solving these questions. So for question number 1, we have find a set of values of k for which the line y is equals to 4x minus 3 does not intersect the curve y is equals to 4x plus 8x minus 8. So basically what they're saying is that we do not have any intersection points between these two lines. How do we find this out? We find this out by saying that our discriminant for these two equations should be lesser than 0. And if they're lesser than 0, that means they have no intersection points. First step, what we do is substitute both of these equations into each other. So k multiplied by 4x minus 3 is equals to 4x squared plus 8x minus 8. We solve this up, we get 4kx minus 3k is equals to 4x squared plus 8x minus 8. Okay. Now that's going to give me, if I simplify this up, 4x squared plus 8x minus 4kx plus 3k minus 8 is equals to 0. Now, what we do is now take the common of x to find out the overall coefficient of x. So it's going to be 8 minus 4k plus 3k minus 8 are the constants. So we are not going to simplify or factorize them. So a is equals to 4, b is equals to 8 minus 4k, and c is equals to 3k plus minus 8, sorry. We substitute this into our equation, b squared minus 4ac is lesser than 0. So if b squared, 8 minus 4k whole squared, minus 4 multiplied by a, which is 4, multiplied by c, which is 3k minus 8. Simplify this, a minus b whole squared is equals to a squared, which is 8. 8 is 64. Minus 2 multiplied by 8 multiplied by negative 4. So 8 to the 16. 16 multiplied by negative 4 is going to be negative 64k. Plus b squared, which is going to be 16k squared. Minus 4 4 is 16. 16 multiplied by 3 is equals to, what 16 multiplied by 3? I guess it's 48. Let me check. 16 multiplied by 3 is equals to 48. Minus 48k plus 16 multiplied by 8, which is 128. And this whole is going to be lesser than 0. Simplify this equation, 16k squared minus 64k here minus 48k. So minus 64 minus 48 is going to be negative 112. Okay. 128 plus 64 is equals to 192. So plus 192 is lesser than 0. We take 16 as the common, k squared minus 7k plus 192 divided by 16, 12. Second, plus 12 is lesser than 0. Now we have got this equation because 16 divided by 0 on the other side is going to be 0. So what I'm going to do is directly put this into my calculator. I've got 1k squared minus 7k plus 12 is equals to, we are getting two values for x. X equals to 4 and x equals to 3. Now, again, for your easiness, I'm going to draw a mini graph from point 3 till point 4. We have got two intersection points of a curve. And what they're asking us are the values which are lesser than 0 for this curve. So we are going to say that x is going to be greater than 3, but it's going to be lesser than 4. And that's going to be our answer. By the way, they told us to find the value in terms of k. We found the values in terms of k, so we are going to say not x, but k. My bad for this one. I changed the variables. So it's going to be k is equals to 4 and 3, and k is greater than 3, but lesser than 4. That is it for question number 1. It was quite easy. For question 2, it's going to be a short one. X multiplied by x plus 2 is lesser than x, and we have to find the values of x for which this equation is going to be satisfied. So it's really simple. You just solve the equation, or you can say the inequality. So it's going to be x squared plus 2x minus x is lesser than 0. X as the common, x plus 1 here is lesser than 0. Why I've done this? Because x squared plus x is lesser than 0. So if we take the x as the common, we are going to be left with x and x plus 1. So we are going to get two values for x equals to 0 and x equals to -1. What we need is the values which are lesser than 0. Which are lesser than 0, which means this point. So x is going to be greater than -1, but x is lesser than 0. And that's it. This is it for question number 2. This was really simple. Proceeding on to question number 3. Okay, so for question number 3, what we are asked is 2x squared minus x plus 6 is to be converted into this form. Okay. And when we see this form, we may say that we can do this by doing the completing the square method. Well, you can do that also, but I want to introduce you with another method, which is the comparison method. And what we do is we compare both of these equations. So for that, what I'm going to do first is 2x squared minus x plus 6 is going to be equals to p multiplied by x minus q whole squared plus r. Okay. And what I'm going to do is open this factorized method equation. So what I'm going to get, p as the common, x minus q whole squared is going to be open. A squared is going to be x squared. Minus 2ab is going to be -2qx plus b squared, which is going to be q squared plus r. Again, simplify this further. Px squared minus 2pqx plus pq squared plus r is equals to 2x squared minus x plus 6. Okay, so now what we are going to do is, that's where the comparison method comes. We're going to compare the coefficient of x squared, the coefficient of x, and we're going to compare the constant as a different personality. So what we're going to say is the coefficient of x, so 2x squared is equals to px squared. What's going to happen, x squared and x squared are going to be cancelled down. By the way, it's -2qx, sorry. So 2 is equals to p. For the other part, we have -2pqx is equals to -x. Negative and negative is going to cut down, and as this all is being multiplied, we are going to cut down positive x and positive x. So we are going to get 2pq is equals to 1. We already knew that p is 2 from this equation. So 2 to the 4 is equals to 4. 2 to the 4. So it's going to be 4q is equals to 1. And q is equals to 1 over 4. That's the value of q. And for the constant r, we are going to say pq squared plus r is equals to +6, as that's the constant here. So we already knew the values of P and Q. So we're going to say P is 2 multiplied by 1 upon 4. 4 is a 16. So it's going to be 1 upon 16 plus R is equals to 6. So 2 divided by 16 is equals to 1 upon 8. R is equals to 6 minus 1 upon 8. And R is in the end going to be equals to 47 upon 8. Okay. So in the end, our equation is going to be something like this. So we substitute the P, Q, and R value. So we are going to get P, which is 2, multiplied by X minus Q, which is 1 upon 4, X minus 1 upon 4 whole squared, plus 47 upon 8. And that's our answer. We could have done this through the completing the square method, or again, we could have done this by the comparison method. I prefer to do it through the comparison method as I find it easier, but it depends on you in the end. For part B, what they've asked us is, hence state the least value of 2x squared minus x plus 6 and the value of x at which this occurs. So they basically are asking for this equation, what would be the least value we can get, and we also have to tell the corresponding x value for which this minimum value comes. Now, if you have concentrated in my previous lectures, we have discussed that it is much more easier to find the least value of an equation by using its completed squared or completed squared form. So basically, we can really easily find it through that. We know that if we open a squared, what can be the lowest value we can get from a whole squared value? The least value we can get is 0 itself. Because why is that? Because if we take -2, for example, it's not going to give out the least value, because -2 whole squared would be equals to +4. Okay. So whenever we have a squared, if we want a minimum value from that squared, we have to have 0. Okay. No negative value can come out from a square. Okay. So the minimum value, again, I'm repeating, the minimum value we can have from a square is 0. And how can we make this a 0? X minus 1 upon 4 whole squared can be made into 0 when we take the value of x to be 1 upon 4. So x equals to 1 upon 4. And then we will have the least value out of this square. So 2 0 is 0. And we are going to get the least value is equals to 47 upon 8, because 2 multiplied by 0 is going to be 0. So 47 upon 8 is our least value. And this least value occurs when we input the value of x to be 1 upon 4. So that's basically it. It's a little bit conceptual, but you'll get the hang of it when you solve more questions. Okay. So for question number 4, what they've told us, they've given us an equation, and they've told us that this curve lies below the, or in fact, they've asked us the set of values for k, for which this curve is going to be below the x-axis. So when anything is below the x-axis, we know that its y value is going to be lesser than 0. And as we discussed in the discriminant, that when the discriminant b squared minus 4ac is lesser than 0, it's also below the x-axis. You can say that. Okay. So what's going to happen here? We take this up, y is equals to a is equals to k plus 1 whole squared. In fact, sorry, k, a is equals to only k plus 1, b is equals to -3, and c is equals to, again, k plus 1. So substitute this into the equation b squared minus 4ac. So it's going to be 9 minus 4 multiplied by a, which is k plus 1, multiplied by c, which is k plus 1 again. Simplify this, and we're going to say this is lesser than 0. So 9 minus 4k minus 4 multiplied by k plus 1 is lesser than 0. So we are going to get 9 first. We are going to use the FOIL method, multiply the first values of these both brackets. So negative 4 multiplied by k, so negative 4k squared. Outer minus 4k, inner minus 4k, and last, which is going to be negative 4. And this whole is going to be lesser than 0. So we are going to get negative 4k squared minus 8k. 9 minus 4 is going to be positive 5, and this whole is lesser than 0. So what we're going to say is 4k squared plus 8k minus 5 is lesser than 0. This one is a really basic equation. So what I'm going to do is solve this through my calculator. So positive 4, positive 8, and negative 5. We're going to get two values for this equation. X is equals to negative 1, x is equals to positive 1 upon 2, and x is equals to negative 5 upon 2. So they asked us the value which are lesser than 0, and we're going to say that our answer is x is greater than 1 upon 2. Sorry, x is greater than negative 5 upon 2, but lesser than positive 1 upon 2. And that's our answer for question number 4. For question number 5, what they've asked us is find a set of values of k of x for which x squared is lesser than 6 minus 5x. So again, it's really simple. We just have to solve this equation up. So x squared x squared plus 5x minus 6 is lesser than 0. This one's really simple. Again, I'm going to use my calculator directly for this one. So 1x squared plus 5x minus 6 is equals to x equals to 1 and x equals to negative 6. So we have two values for x, and what they've asked us are the values which are lesser than 0. So from negative 6 till 1, got something like this. And they asked us the value which is below the curve. So we can say that x is actually greater than negative 6, but it is lesser than positive 1. So that's it. This is for question number 5. Really simple. It's just all about your concept being clear. And if that's clear, you can easily solve every single question. For question number 6, however, we have find the values of k for which the line y is equals to k minus 6x is a tangent to the curve y is equals to this, and this. So what they're saying is that we have a curve, something like this, and we have another line which is acting as a tangent to this curve. And we know when something is a tangent of a curve, we know that it's going to intersect at only one point of the curve. So as we know that b squared minus 4ac, when it's going to be equals to 0, we are going to get only one intersection point. And that's what they are demanding us. So step 1, we substitute both of these equations. K minus 6x is equals to x multiplied by 2x plus k. Okay. So k minus 6x is equals to 2x squared plus kx. Simplify this equation. 2x squared plus kx plus 6x minus k is equals to 0. We take x as the common, 2x squared plus x here common, k plus 6 here, minus k as the constant. So our a is equals to 2, b is equals to k plus 6 as a whole, and c is equals to negative k. Substitute this into our equation. B squared is going to be k plus 6 whole squared minus 4 multiplied by 2 multiplied by negative k. Simplify this, a squared, k squared, plus 2 multiplied by k multiplied by 6 is to the 12k, plus b squared, which is 6 6 are 36, minus 4 to the 8, and it's going to become positive 8k is equals to 0 because there's only one intersection point. So k squared plus 20k plus 36 is equals to 0. I'm going to take my LCM for 36. 3 1s are 3, 3 2s are 6, 3 4s are 12, 2 2s are 4, 2 1s are 2. We have to construct 20 out of this, so 2 2s are 4, 4 3s are 12, 6 3s are 9, 9 2. Okay, so it's going to be k squared, 9 2s are 18, so it's going to be plus 18 plus 18k plus 2k plus 36 is equals to 0. K is the common, k plus 18, and here we get 2 as the common, k plus 18 is equals to 0. So we have got two values for k. K is equals to negative 2 and k is equals to negative 18. So that's it. We can say that the values for which the straight line is a tangent to the curve is negative 2 and negative 18. So that's it for today. I'll try to wrap up the whole exercise by the next lecture. So thank you for watching this lecture. See you.